Hey guys, once again welcome to my channel Medicinal Pharma Education. In this video we are going to discuss the main topics: spin coupling, spin decoupling, coupling constant, and the nuclear magnetic double resonance. Okay, nuclear magnetic double resonance we'll discuss in the next video. We'll complete spin coupling, spin decoupling and coupling constant in this video. Okay, I hope you are doing well, study well and get good marks in your semester exams. Do your masters very well. Without wasting any time, we will start with the topic, today's topic. Okay guys, please try to watch the previous videos so that you can understand this topic clearly. If you are not watching the previous videos, you will not understanding this topic, because every topic is related to the previous video. The NMR signals or etc is related to the previous videos. If you have understood that previous videos, then you can understand this video. So that please watch the videos and come here. Okay, spin coupling, or it is also called as splitting. This is very important term, splitting. According to Dirac model, electrons in the bonding between two nucleus transfer spin information from one nucleus to the another by means of interaction between nucleus and electrical spin. See here, two nucleus transfer the information from one nucleus to another by the nucleus and electrical spin. By using of the electrical and the nucleus, the information is transferred between the nucleus. Okay, spin coupling occurs due to unpairing of bonded electrons. Okay, this it's not definition, I'm just telling how the information is transferred between two nucleus. Okay, here you just see, spin coupling occurs due to unpairing of bonded electrons. Okay, the interaction of spin of neighboring nucleus in a molecule causes splitting of lines in the NMR spectrum process, and the process is known as spin splitting, and this process is known as spin splitting. The this is an disadvantage. Spin splitting, what happening, right? I'll just show you by an diagram. See what is happening. Just first see the definition. The spin of neighboring nucleus in a molecule causes splitting of lines in the NMR spectrum. See NMR spectrum, you know, right? NMR spectrum, this is the spectrum. If you see spectrum, this neighboring atom, what it causes, right? It gives new number of lines, new number of peaks than rather than the original one. This is the original one. This neighboring atom, if it is interacting with a neighboring atom, right, this gives its own signals, and by this we will deviate from the result. This is happening. This is called spin splitting. Okay, spin coupling or splitting. See the definition is telling the interaction of the spin of neighboring nucleus in a molecule causes splitting of lines. That's what I said, splitting of lines in the NMR spectrum, and process is known as spin splitting. Why spin splitting is caused? See, there are mainly two reasons: difference in environment of absorbing proton with respect to the neighboring proton. Here, if the environment of both protons are different, then this occurs, and difference in spin state and induced magnetic field. Okay, due to these two reasons, the spin coupling or splitting occurs. I hope you are understanding. There is nothing, if here in NMR spectrum, as NMR spectrum comes, this is the original NMR spectrum of the sample, but due to interaction with the neighboring nucleus, there is causing splitting of lines. This is unwanted. Due to this, the analyzing of the sample is difficult. Okay, next we'll study the spin splitting in H1 NMR spectroscopy, hydrogen 1 NMR spectrum. See, peaks are often split into multiple peaks due to magnetic interaction between non-equivalent proton on the adjacent carbon, and this process called spin-spin splitting. See, already we have discussed the same here. Peaks are often split into multiple peaks. Here what we said, due to interaction of neighboring nucleus, the splitting of the original NMR spectrum is happening due to magnetic interaction between non-equivalent proton on the adjacent carbon. This process is known as spin-spin splitting. We have already discussed. Hope you are understanding. The splitting is into one more peak. Splitting is into one more peak than the number of H1 protons on the adjacent carbon. This is N1 plus 1 rule. N plus 1 rule. See, if the splitting, if N is 1, then the splitting is 2. Okay, you will understand by this triangle. The relative interactions are in proportion of the binomial distribution by Pascal's triangle. See, if N is 1, then if N is 1, then it is N plus 1 is 2, then it is doublet. Okay, you just see this triangle. By the triangle we understanding how the splitting occurs. If N is 0, then singlet. N is 2, then doublet. Here singlet means this is a singlet. Doublet means it has 2 number of protons. Triplet 1 is to 2 is to 1. See, by this triangle we will understand how the splitting occurs. 1. Next, doublet 1 plus 1 2. Okay, triplet 1 plus 2 3, 2 plus 1 3. Quadruplet 1 is to 3 is to 3 is to 1. If it is present in this way, then it is a quadruplet. If it is present in this ratio, then it is penta, hepta. If the ratio is present in this way, then it comes in this way. We will just understand. You just see this example, you will understand. For determining the splitting of this compound, see, we have discussed these protons are different from this proton because these protons are closer to these protons and these protons are far. So that there are two types of protons, A and B. There are two signals. If N equals to CH, for CH3 N is 2 because 2 protons. For CH2 3 because this has 3 protons. So N equals to 2 and N equals to 3. We substitute in the N plus 1 rule. Then N plus 1 equals to 3, triplet state. This gives triplet, means this signal. Triplet means gives this signal. Okay, this CH3 gives triplet signal. Okay, and this CH2 gives quadruplet, means this signal. Okay, I think so you have understood by this example. This by this we will tell what, by this, using this formula we will tell what type of signal it is giving. It is giving a singlet, doublet, triplet, quadruplet, penta, or hepta, or hexa, or hepta. Okay, I think so you understood this example. Just to see the example and substitute the value in the formula, and you will get triplet or quadruplet. We will see more number of examples so that you will understand in a better way. See, here these protons are different from these protons, and these protons are different from these protons, and these protons are different from this protons, because these protons are very far from this oxygen. These protons are a little bit far from the proton. These are very equal. These are very close. See, these protons and these protons, you think they are similar, but they are not similar. They are similar in number of hydrogens, but the neighboring atom is dissimilar. If CH2 is replaced with O, then these two are equal. So we have 4 types of protons, 4 different types of protons, A, B, C, D. Okay, then if number of different types of protons are equal to number of signals, okay, then we have 4 signals. See, for CH3A, N equals to what? how many neighboring hydrogens we have? N equals to 2. Okay, 2 plus we substitute in the value, 2 plus 1 it gives 3 spins, means triplet. Okay, same you do it for CH2. CH2 has here this side has 2 and this side has 3, 2 and 3. You just by this you substitute the formula, by this way you just substitute it, 2 plus 1 for A and 2 plus 1 for C. Okay, 3 for what is A here? 3 plus 1 for A and 2 plus 1 for C. 4 plus 3 is 12. Okay, it has 12 signals. Okay, what it not signals, 12 spectrums, 12 NMR spectrums. Okay, and for CH2 N is equals to 2. Why CH2? See, this side we don't have any hydrogen and this side we have 2, so N equals to substitute in this value 3 spins. And for CH3 N equals to 0, then it is singlet. We have discussed, if it is there is no, if N is equals to 0 then it is singlet. This is the homework. If you are understanding this concept, tell me the fourth comment, mention in the comments this fourth one and fifth one, A, B, C, D and A, B and C. Okay, you just tell me what are the signals of the third and fourth. Okay, so that I can understand you have understood the concept. CH3, CH2, CH2 and OH. CH3, C11O, CH2, CH3. Okay, next, coupling constant. Coupling constant is nothing but, see, the distance between these two peaks, right, that is called J, that is coupling constant. The distance between these two, these two or these two is called J, that is the coupling constant. Just see here, the spacing of adjacent lines in a multilet is a direct measure of spin coupling, is known as coupling constant. See, the spacing of adjacent lines in a multilet in a direct measure of the spin coupling is called coupling constant. That I'll show you, right? The distance between two peaks is called J, and it is coupling constant. It is the distance between two adjacent sub peaks. J value is expressed in hertz or cycle per second. I hope you are getting the point. See here, you take example for this one, Cl carbon Cl, and we have these two protons are same and this is different, and we get the spectrum, and the distance here, the distance between here is 6.1 hertz and here is 6.1 hertz. The distance between the two peaks, distance between these two sub peaks, the distance between these two sub peaks is 6.1 hertz. That's the value, or it is called as it is called as coupling constant. Okay, for non-equivalent hydrogens on the same sp2 carbon, the J value is usually very small and are unstable to observe. See, for equivalent hydrogens, they are very unstable and very small, they are unable to observe. But for non-equivalent hydrogen are bonded to adjacent sp2 carbon, the J value is large and they are observed. Okay, here the difference between those two, here on the same sp2 carbon, on the adjacent sp2 carbon, if adjacent it is there, J value is large and it is observed. If adjacent is not there, then it is very small and it is unstable. That's the basic difference. Hope you are understanding this concept. If you have not understood, just watch it again, you will understand it. It's like a little bit tricky, but it's very easy. In the next video we will start with the nuclear magnetic double resonance. Nuclear magnetic double resonance is completely related to these above topics, and in 2 videos we will complete NMR spectroscopy. Thank you guys for watching. Have a nice day. Take care. Bye. See you in the next class.